Okay, so in this video we're going to discuss the quotient rule. So in the last one we saw what to do when you're dealing with a product of two functions. Now we're going to look at what happens when you've got a quotient. So you've got one function divided by another. For example, if we have a rational function, how do we handle that using the quotient rule? Well, here's what the quotient rule says. If you've got two differentiable functions, then their quotient, f over g, will also be differentiable as long as the function in the denominator is non-zero. And the formula for the derivative, well, you can see it sitting there. It's a pretty ugly looking formula. It's not all that different from the product rule formula, right? Notice that we do the derivative of f first, and then we do the derivative of g. But beware, this time there's that minus sign in the middle, so you've got to be a bit careful about the order here. The one that's on the bottom comes with a minus sign, right? So if you think in terms of, this is kind of like f times g to the minus 1, right? Anything in the bottom has a negative exponent. So that's the one that gets the minus sign. And then there's this g squared on the bottom. So that's, again, something that you've got to keep track of, that you're going to have to remember. But this is something which, it looks intimidating when you first see it. Once you sit down and you do 4, 5, 6 examples using the quotient rule, you'll get the hang of it pretty quickly. And once you get some practice, it's not too hard to work this out. Okay, so let's look at some examples. If I want to take the derivative of, let's say I have a rational function. So I have something like x squared plus 3x minus 2 over x cubed, let's say 2x cubed plus 5x, okay? So I do the derivative of the top times the bottom minus the top times the derivative of the bottom. Let's just put brackets there to be careful. Whole thing is divided by the bottom squared. Okay. So once we take our derivatives, let's see, the derivative of the top, we get 2x for the derivative of x squared, 3 for the derivative of 2x, and of course the derivative of that minus 2 is 0. It's a constant. 2x cubed plus 5x minus, and so now we do x squared plus 3x minus 2 times the derivative of the bottom. So the derivative of 2x cubed, well, the derivative of x cubed is 3x squared, times 2 I get 6x squared, and then the derivative of 5x is simply 5 over the derivative of 2, oh, don't forget to square it, 2x cubed plus 5x, and the whole thing is squared. Okay, let's do one more example. So let's say I want to take the derivative of the tangent function. So we know that tan x is sine x over cos x. And so if we want to take the derivative, we're going to need the quotient rule. So what does f prime look like? F prime of x looks like, so again, we do the derivative of the top, the derivative of sine x times the bottom, which is cos x, minus the top times the derivative of the bottom, which is cos x, and we divide by the bottom squared, so cos squared x. Okay, so what's the derivative of sine? The derivative of sine is cos, right? So we get cos x times cos x minus sine x times, what's the derivative of cos? Remember, the derivative of cos is minus sine x. Over cos squared x. Okay, so that's the derivative, but you know what? We can actually clean this up quite a bit, because what do we have here? What do we have here? This is cos squared x minus plus sine squared x. What's sine squared plus cos squared? That's 1. So we've just got 1 in the numerator, cos squared in the denominator. So f prime of x is in fact just 1 over cos squared x, which we can also write as secant squared x. Okay, I left one more slide for the proof of the quotient rule, but I think we'll skip it in the video. It is in the textbook if you want to look it over and see the details there. We'll leave it at here for now.